We're still on exponential equations. This time around, we are looking at exponential equations that involve quadratic. On the screen, we have 3 raised to the power 2x minus 12 into 3 raised to the power x plus 27. This kind of exponential equation, when we reduce, we'll first of all reduce it to a quadratic equation. Let's see how that goes. Here we have 3 raised to the power 2x minus 12 into 3 raised to the power x plus 27 equal to 0. The first thing we do is that since I have 3 raised to the power x here, I look at this side. This is 3 raised to the power 2x. Can I get 3 raised to the power x out of this? I think so. I use the idea of multiple indices and put my x in there, and I take the 2 outside. Yes, x times 2 will still give me my 2x. So I've done nothing there. Minus 12 into 3 raised to the power x plus 27 is equal to 0. Now that I've arrived at this point, I simply find something to replace my 3 raised to the power x. And I say, okay, let me use something like k. If I say let k replace 3 raised to the power x, it means that this expression, the second line, can be written as k squared, as in place of 3 raised to the power x, minus 12k plus 27 equal to 0. That's exactly what I have here. First, I've reduced this to 3 raised to the power x all square, because x times 2 will give me my 2x back there. And then, of course, I've touched this side. I've not touched this side at all. Now, I've replaced my 3 raised to the power x, which seems to be consistent across the equation, and I replace it with k. And replacing it with k, I obtain this equation. But before coming here, we all know how to solve quadratic equation. If you cannot solve that, please go back and check our video on quadratic equations. But I'll take a very quick one here. Let's look at this together. K squared minus 12k plus 27. Please take note, this is not class. This class is not for quadratic equation, but I'll still go ahead and do it as fast as possible. We're supposed to look for factors of 27 that can help us to replace minus 12. Factors of 27 are 1 times 27, 3 times 9. I think that's all. Now, this is positive, meaning that both of them must have the same signs. And this is negative, meaning I'm going to use minus, minus. So I have here k squared minus 3k minus 9k. Remember, we're supposed to replace our 12 with the factors of 27. So the factors we have chosen is minus 3, minus 9 to replace minus 12. And then we have our plus 27 equal to 0. So that's what we have on this line. Now factorizing this, we have here k into bracket. K squared divided by k is k. Minus 3k divided by k is minus 3. If you think you can catch up with the speed, check the video on solving quadratic equations. We bring 9 out. Between 9k and 27, 9 is common. Minus 9k divided by minus 9 is k. Plus 27 divided by minus 9 is minus 3. And we have here k minus 3 into k minus 9 is equal to 0. Of course, from here we can solve that our k is 3 or 9. Yeah, that's what we have there. But take note, the question did not demand that we should look for k. Rather, we are supposed to solve this equation to obtain the value of x. So we now have to look at when our k is 3, what will be the value of x? Because we have said that k is equal to 3 raised by x. When our k is 9, what will be the value of x? So we'll advance to look at that. So we see here, when k is 3, there, what is x? Oh, we say, okay, k is 3. That means k is 3 raised by x, which is 3 now. Solve this simple exponential equation. We know that means 3 raised by x is equal to 3 raised by 1. So our x is 1. Similarly, on this other side, when k is now 9, we say, okay, that means our k is what? 3 raised by x equals to 9. Oh, 9 is 3 raised to the power 2. That means our x is equal to 2. So we have finally solved this equation and we have obtained that our x is equal to 1 or 2. Please take note that the question demands that you should find x, not k. We only brought in k just to help us simplify things. Let's take another example. Here we have 2 raised to the power 2x plus 1 is equal to 33 times 2 raised to the power x minus 6. I can see 2 raised to the power x, so that's like our joker. So I'll try to rearrange this again. First and foremost, so this is 2 raised to the power 2x plus 1. I collect everything to the left hand side. So this is 33 times 2 raised to the power x minus 16. So this will be plus 16 if I transfer to the left hand side. And that will give us equal to 0. I have 2 raised to the power x here and I look at this. Can I get 2 raised to the power x from this? Yes, but this plus appears to be a problem. Then I remember the very first equation of motion, a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. So okay, so this 2x plus 1 can be written as 2 raised to the power 2x times 2 raised to the power 1. Okay, so the separation is coming out gradually. Let's write this out. 33 2 raised to the power x plus 16. Let's work on this a little bit more. 2 raised to the power 2x. I'm interested in getting 2 raised to the power x. So I play this again. The same thing I did in the previous one. I get 2 raised to the power x and I raise this to the power 2. So that 2 times x will give me my 2x back. And this is times 2 raised to the power 1. Oh, that means just multiply this by 2. Yes. I just keep that 2 there. That's 2 raised to the power 1. Minus 33. This is 2 raised to the power x plus 16 equal to 0. You can see the joker is just in this place, being able to split this out using this relationship. And then we play this one again out using the multiple indices concept. I can now say let something replace my 2 raised to the power x and let something replace this 2 raised to the power x. What do we use? We can say m or whatever should replace 2 raised to the power x. So we have it there. If m is replacing 2 raised to the power x, that's our 2 raised to the power x all square. It means I'm going to have m squared. Remember, I still have the 2 standing by times 2. That's 2 raised to the power 1 there. Minus 33m plus 16 equals to 0. And of course, we can write this out neatly as 2m squared minus 33m plus 16 equals to 0. So here we just have a quadratic equation again to solve. And we can now speed up things a bit. Let's solve our quadratic equation. 2m squared minus 33m plus 16 equal to 0. Please, if you do not understand how to solve this using the factorization method, as I said earlier on, consult the video on solving quadratic equations. Here I'm going to do 2 times 16. I obtain 32. So I'm going to look for factors of 32, which will be 1 times 32, 2 times 16. What else? 4 times 8. I think that's all. Yeah. Of course, we are looking for 33. We are going to use minus 1 minus 32 to obtain minus 33. So I'm going to write here 2m squared. In place of 33, I have minus 1m minus 32m plus 16 equal to 0. Factorizing, what is common here? M is common, so we have 2m minus 1. I'm sorry, I have to move faster. This is not the class for quadratic. This is 2m plus 16 minus, okay, that's minus 1. Sorry about that. This is equal to 0. And we have here m, 2m minus 1, that is common, m minus 16 equal to 0. Now solving this, we're going to obtain 2m minus 1 equal to 0 or m minus 16 equal to 0. If we solve this, we obtain m as what? 1 over 2. And here we solve m equal to what? Equal to 16. Let's write this out in the neater form. That's it there. Yeah, where we substitute our m there, and we have m squared times 2, which is 2m squared minus 33m plus 16. Solving the quadratic equation, we obtain our m as 1 over 2, and we obtain our m here as 16. Now take note, the question again did not demand that we should solve for m. If you look at the equation that was given to us, we're supposed to get x. So how do we get our x? We recall that we had earlier said at this point that m is equals to 2 raised to power x. So when our m is half, because here we have obtained m as 1 over 2 or 16, then we now have to use each of them to find the value for x. So when m is 1 over 2, that means that 1 over 2 is equals to 2 raised to power x. Yes, from this expression. Oh, linear equation again, sorry, simple exponential equation here. This can be expressed as 2 raised to power minus 1 equals to 2 raised to power x. And oh, that means our x is minus 1. That's it for that. Then when m is what? The second one says m is 16. That means that 16 is 2 raised to power x. Again, from this line. Now, how do we solve this? Oh, 16 is 2 raised to power 4. That's 2 raised to power x. Of course, you agree with me here that 4 is equal to x. That means x is equal to 4. So we obtain two results there. X is equal to minus 1 or 4. And that's what we have there. Therefore, x is equal to minus 1 or 4. So that's it for this video clip. We'll take one more video clip to round up exponential equations.